Hopefully you've all had a straw and you've blown bubbles. My question is, what are in the bubbles? Most people will say that the bubbles are filled with air, and that's a good answer. A slightly better answer is that they're filled with gas, because that's more general. The real question is, what kind of gas? Today we're going to look at chemical reactions that generate 3 different kinds of gases. Let's take a look.
Actually do it.
In this chemical reaction, you'll see I'm pouring a liquid into a beaker. The liquid is vinegar, and the powder that's in there is baking soda. And what you'll see happening is a chemical reaction between the vinegar and the baking soda that creates some foam or fizzing. And we know fizzing and foam mean bubbles. Bubbles means gas. And if we watch what happens as the gas bubbles pop, the candle goes out. That's telling us that the bubbles of gas are filled with a particular kind of gas. That gas is carbon dioxide. So if you remember, we did the baking soda mixed with the vinegar and it gave us these products. We can easily recognize that one as water. And then the bubbles were filled with CO2 gas, and that's why I put the candle out. So again, we can see it's one of the products of the reactants, and it's a gas and it makes a bubble, and we can test for it. Let's watch this reaction one more time. Bubbles form, bubbles of carbon dioxide get popped, they release the carbon dioxide, and the candle goes out. This is H2O2. I'm going to put a little in here with yeast and watch the reaction. You can see these nice bubbles in here. And so what I want is a glowing splint, so I'm going to shake this out so there's no fire. Now it's a glowing splint. And when you put a glowing splint in here, you'll see it flashes like that, and it relights. And that tells us that there's oxygen in that gas bubble. So those bubbles are filled with gas, and when I pop one of them, you can see the glowing wood splint reignites. So in this reaction, you remember we take the hydrogen peroxide, we smash those together, and the yeast helps that reaction happen. It sort of acts as a catalyst to speed it up. When they smash together, those atoms rearrange to form 2 water molecules and 1 oxygen molecule. And you'll remember that oxygen is a gas at room temperature, so it basically makes a gas bubble in the liquid, and that's what we see inside the yeast hydrogen peroxide mixtures. Those bubbles are filled with oxygen. So it's a glowing splint, doesn't have a fire on it, and I pop a bubble in here and it reignites. And that tells us that that bubble was filled with oxygen. In this reaction, I'm going to take hydrochloric acid, which I put here, and I'm going to mix it with some zinc, which is in this bottle. Zinc looks like this. It's a metal. So it's a hard silver metal. And what I'm going to do is I'm going to put it in the hydrochloric acid. So I've got that zinc bubbling away there, and I'm going to try to capture the hydrogen in that tube like that. For this test, I want a flaming wood splint. So in the zinc and hydrochloric acid reaction, we have a zinc atom smashing into the hydrochloric acid. And again, the atoms rearrange to form zinc dichloride, which is basically those 2 chlorines attached to the zinc. And we get hydrogen atoms combining into a hydrogen molecule, and they form a bubble in that liquid. And again, we have a gas bubble, and this is the gas that's in the bubble. And we can see that reaction. We can capture that gas and do a little test on it. So zinc and hydrochloric acid make bubbles of hydrogen. Then we collect that hydrogen in a test tube and do a flame test. What we should see inside this tube is a slight fog, and that fog is the result of the hydrogen molecules smashing into the oxygen and making a fine mist of water. You can see how it's a little foggy in there. So what we're seeing is this reaction, and we trapped hydrogen, so the product of this reaction becomes a reactant of the new reaction. What we have happen is the hydrogen molecules smash into the oxygen molecules that are in the room. The chemical reaction happens, which causes the pop, and you form two water molecules, and that's what the fog is on the inside of the test tube. The pop makes water molecules which form a fog inside the test tube.